How many particles are present in 0.1 moles of sodium atoms? 6.022 times 10 to the 22, 6.022 times 10 to the 23, 1.20 times 10 to the 23, or 0.10? The answer is 6.022 times 10 to the 22, because 1 mole's worth of sodium atoms would contain 6.022 times 10 to the 23 atoms. This would be Avogadro's number. So in 0.1 mole, there'd be 10 times less number of particles. How many moles of hydrogen atoms are in 2 moles of NH3? 2 moles, 3 moles, 6 moles, or 8 moles? The answer is 6 moles, because the formula of ammonia, NH3, tells us that 1 mole of ammonia contains 3 hydrogen atoms, so in 2 moles of ammonia, there will be a total of 6 hydrogen atoms. Isotopes of the same element differ in their number of protons, number of neutrons, atomic number, or type of bonding. The answer is number of neutrons. Isotopes are atoms of the same element, so they have the same number of protons and atomic number, but a different number of neutrons. Which of the following pairs has the same empirical formula? H2O and H2O2, C6H6 and C2H2, CO and CO2, CH4 and C2H6. The correct answer is C6H6 and C2H2, because remember, the empirical formula of a compound is the simplest whole number ratio of atoms of each element in the compound. In a 200-gram mixture, 50 grams is ethanol and 150 grams is water. The mass fraction of ethanol is 0.25, 0.33, 0.50, or 0.75. The answer is 0.25, because 50 grams is a quarter of 200 grams, which means the fraction of ethanol by mass in a mixture is 0.25, a quarter. Which of the following is the correct ground state electron configuration of sodium? Atomic number 11. 1s2, 2s2, 2p6, 3s1. 1s2, 2s2, 2p6, 3p1. 1s2, 2s2, 2p6, 3s2, or 1s2, 2s2, 2p5, 3s2. The answer is 1s2, 2s2, 2p6, 3s1. Which principle explains why electrons fill the lowest available energy orbitals first? Pauli's exclusion principle, the Aufbau principle, Hund's rule, or Coulomb's law? The answer is the Aufbau principle, because Pauli's exclusion principle tells us that one orbital can hold a maximum of 2 electrons with opposite spin. Hund's rule tells us that all orbitals in a given subshell will be singly occupied before being doubly occupied, so all orbitals fill singly first. And Coulomb's law describes the strength of attraction between 2 oppositely charged particles. So the answer is the Aufbau principle. Electrons always occupy the lowest energy orbitals first. In a photoelectron spectrum from photoelectron spectroscopy, the x-axis is typically labeled as binding energy in electron volts, ionization energy in kilojoules per mole, electron velocity in meters per second, or atomic radius in picometers. The answer is binding energy in electron volts, because photoelectron spectroscopy measures the energy required to remove electrons from an atom, and this energy is measured in electron volts. and the height of the peak is related to the number of electrons in the subshell. The area under a PES peak is directly proportional to the number of orbitals in that subshell, the number of electrons removed from that subshell, the ionization energy of the subshell, or the relative atomic mass. The answer is the number of electrons removed from that subshell, because remember, in photoelectron spectroscopy, we measure the binding energy of electrons to the nucleus of an atom, and the graph produced is called a PES spectra, with each peak corresponding to a particular subshell. Across a period from left to right, atomic radius generally increases, decreases, stays the same, or oscillates. The answer is decreases, because as you move across a period, the number of protons in the nucleus of the atom increases, meaning a greater positive charge, but the number of electron shells remains the same, meaning a similar level of shielding. This results in a greater force of attraction between the outer shell and the nucleus, pulling the outer shell closer to the nucleus and giving the atom a smaller atomic radius. Across a period, electronegativity generally decreases, increases, remains constant, or varies randomly. The answer is increases, because as you move across a period in the periodic table, the nuclear charge increases but the atomic radius decreases, meaning bonding electrons are closer to the nucleus of the atom, meaning a greater strength of attraction to the nucleus, giving the atom a higher electronegativity. Which element deviates from the smooth first ionization energy trend across a period due to starting to fill a new subshell? Boron, nitrogen, neon, or magnesium? The answer is boron, because boron has a slightly lower first ionization energy than the element before it, beryllium. This is explained as the electron that is removed from a boron atom comes from a 2p subshell, whereas the electron removed from the beryllium atom comes from a 2s subshell. The slightly higher energy subshell means it's slightly easier to remove the electron from boron compared to beryllium. Down a group, first ionization energy generally increases, decreases, stays the same, or becomes random. The answer is decreases, because as you go down a group, the outermost shell gets further away from the nucleus of the atom, meaning a weaker attraction from the outer electrons to the nucleus, meaning they're easier to remove. How many total electrons are transferred when forming Al2O3 from neutral atoms? 2, 3, 4, or 6? The answer is 6, because each Al will lose 3 electrons and each oxygen will gain 2 electrons. Well, 2 aluminiums losing 3 electrons means 6 electrons get lost by those, and 3 oxygens gaining 2 electrons means 6 electrons get gained by the oxygen atoms. So 6 electrons are transferred in total. Which pair forms an ionic compound most readily? Carbon and oxygen, hydrogen and oxygen, nitrogen and chlorine, potassium and sulfur. The answer is potassium and sulfur, because this pair has the greatest difference in electronegativity, with potassium being a metal that will likely form positively charged ions, and sulfur being a nonmetal that will likely form negatively charged ions.